time, I'm gonna hand back some chapter reviews. We're gonna review for a chapter review test next week. And then and I'm also handing back your fitting makeup exercises. Those grades are not recorded. I don't have the grades, so when I give these back to you, Jesus, what you've got the option of doing is keeping the grade, repairing it, resubmitting it, whatever you need to do. But if you want that grade or a grade, I have to get something back. So I've got some blank fitting makeup exercise, and not tonight, y'all can take it home with you and work on it. I've got some of the blank fitting makeup handouts right up here, Carrie. So y'all can take those with you and go home and work on it. I want these back at the beginning of class next week. That way you've got time to possibly look at it, see if there's anything you do or do not understand, and see about making those corrections, Stuart, and getting them back to you. There it is, Joe.
I believe that in the test.
We're just handing stuff out right now. So on these fitting makeup exercises, like I said, I have not recorded these grades. Elliot? So whether it's this, or you take it and make changes, corrections, whatever, get those back to me so that I can record these grades. So right now, it's like they were never turned in. You get a mulligan if you need it. All right, Colton? Erica? Shamir? Joe, I'll move those in just a second. I didn't know you was gonna be here, so I set all those out. You didn't hear. Scott?
You already gave me mine Friday.
I got some other stuff for you too.
Okay.
Yeah. Hey Scott, do me a favor, move those 3 stacks up here, please. Taryn? So some of the stuff that I did bring up with your fitting makeup, if you see it circled, so if you have a dimension of, say, 1 foot 6.5. If it is circled and has 1/2 written next to it, don't come up and say, but Mr. P, that's what I put there was 6.5. No, that half is that it is half off. That means you were within an inch of the correct measurement. If you have a red X through it, that means you're at least an inch plus off, incorrect. So I like I tell y'all about my self-checking. I want the same answer twice. I want to see the same answer repeated. That tells me that either I'm wrong twice, or for me, it's confirmation that it's correct. So now that you've had time away from it, now would be a time to not to go back to look at what you did last time and say, where did I make the mistake? Now would be a good chance to say, okay, I missed this one. It's got an X through it, it's more than an inch. It's got a circle on it with a 1/2 next to it, means it's half off, so I'm within an inch. I would say, don't try to figure out the mistake yet. Go through and do the math again from scratch. Look up the numbers. You got another whole week. We're gonna talk about your chapter 8, 9 exercises. We're gonna review for your test next week over chapters 5, 6, and 7 reviews. And then chapter 9 exercises. The chapter 9 exercises, once maybe I give you some tips here in a little bit, maybe all that will clear up for you. And give you time to work on these over the next week. Alright, so everybody clear about the instructions on those? What was some of the other stuff I may have rung up on that? Oh, feet and inches. So if I rang you up for feet and inches, that also counted into your points off. Feet and inches means that you said 6 inches plus 8 inches plus 3 1/4 inches is so-and-so inches. No, remember, anytime that we do math and we cross over that 12-inch mark, we're gonna show it in feet, inch, and fraction. We don't show 0 foot dash 6 1/2 inches. We don't show the 0 feet. We suppress it in AutoCAD's language. But we do show the 0 inches. So if you have that, you see that maybe I put a little red circle inside there. I wasn't saying that you missed something or you left something out other than that actual 0. So if that dimension is 1 foot 0 1/2, we're gonna put that 0 on that measurement. So that's some of the stuff that you may have gotten rung up, so make sure you understand that fit and makeup. In drafting, lots of times we've got to run a pipe. Remember, we measure off center lines. We've got to run a pipe coming here, run a pipe coming here. Y'all saw it in the control valve manifold. We don't need that measurement. It's usually not shown because there's an elbow, a reducer, a flange, gasket, valve, gasket, flange, reducer, elbow. It's fitting makeup. We don't measure that out. So little things like that, being able to add up and look up those correct fittings and the correct measurement needed is a big part of pipe drafting. Alright, so on your chapter 9 exercises, whenever you turn it in, you can just use the same blank master that I gave you for your chapter reviews. It has the chapter, normally you'd have chapter 9 or something like that at the top. This will just be chapter 9 exercises. And then your regular name and everything at the top corner. So what I want you to do is make 3 columns, one for each of those 3 pages that we're about to talk about. You've got 10 questions or 10 measurements to look up on those, each one of those. So just tell me 1 through 10, but just put it all on one page so when we reference back to it, be easier to go back to it and talk about how possibly you may have made a mistake on it. Also, just to see if you follow instructions. So what you've got at the end of chapter 9, now we're starting to take all those different components that we've been learning about, all those different fittings and all those different pipe symbols that we've been trying to absorb and learn what they mean and what they tell us whenever we see them on a drawing. Now we're starting to look at bringing all of them together and putting them together. So as a pipe drafter, one of the first things we have to do is find the equipment. Our pipe doesn't just start in space. Your pipe is gonna start somewhere. Usually your pipe goes from equipment to equipment. You might not be doing the whole phase of that pipe going through it, but the normal pipe run, they call it a spool piece, similar to a spool that you can get thread or string or something on, has the fat ends on it. That's similar to a spool piece. That's where this term spool piece comes from, because we have a flange and a flange on each end. That way they can bring that out to the refinery after it's been fabricated, painted, galvanized, whatever else, tested, x-rayed, bring it out to the refinery, put it up where we can't weld, we can't burn, we can't grind, put it up into place, drop some gaskets in, bolt it up, boom, move on to the next one. So that's where the term spool piece comes from. So as a pipe drafter, it isn't gonna be just a flange on this end, a flange on this end, and a piece of pipe in between. It's gonna be a flange over here on this end and another flange on the other end at a piece of equipment. And then somewhere in between, it's gonna have a bunch of other stuff probably happening. Elbows, T's, reducers, maybe some other lines coming off, stubbing out of it. We're gonna have valving. We might have some of these control valve manifolds in that run. So the pipe drafter goes through and says, okay, I'm going from this piece of equipment to this piece of equipment. Next semester in we'll do chapter 10 in the advanced pipe class. But if you look through chapter 10, it is something, we're not gonna do the chapter review on chapter 10, so don't forget that from real early in the semester. If you work ahead, you don't have to do the chapter 10 review. We don't do that one. We pretty much skip over chapter 10. That's your spring break assignment, actually, is to look through chapter 10. We come back and do chapter 10 next semester. So chapter 10 is very similar to where if you were in industry in an engineering department, in a pipe drafting engineering department at a petrochem facility, that is similar to the packet that would be given out to you. It's got what we call vendor data drawings, which is where we look up the different pieces of equipment to find out information about where our pipe is attaching to. We've got different layouts of the facility that we'll go through and we'll look at that say, here's everything, here's all these pipes. So if you can envision a bowl of spaghetti looking down into that bowl of spaghetti. Lots of times, that's what these facilities look like. Every now and then, you've got a meatball. That's your different, vessels and stuff out there. But mainly, it's just a bunch of, looks like spaghetti running around in there. You as a pipe drafter have to look at that spaghetti and say, okay, here's my pipe going from here to here. And it's not that easy, but what we do is we go to what's called a pipeline list. That's our first stop. And we go there, we say, okay, the boss said I'm doing pipes number 5, 6, and 7. So you look over on that pipeline list. It says pipe number 5 comes from this piece of equipment to this piece of equipment. Pipe number 6, this piece of equipment. So now you can go back to that spaghetti bowl. You can find that piece of equipment. You can find your pipe, and then you can trace it through there to the other end, to the other piece of equipment. So this is kind of setting up, bringing some of that stuff together. As a pipe drafter, we have to find those pieces of equipment. And we have to start our measurements from there. So that's gonna tell us where this end starts at, where this end starts at. Like I said, it's never just a straight line with flanges on the end, but if you could envision something as simple as that. That's the basics of it, is we're going from this piece of equipment to this piece of equipment, and we've got a bolted connection on each end because we can't weld out there. So we've got to find information on this end of our pipe and information on this end of our pipe. Because that vessel, that pump, all these pieces of equipment, the civil, the concrete that was done under there, all the structural steel that our pipe is sitting on, is not being done by our company. Some of it is possibly being built in another country even. So it's not like we can go out in the backyard like we do with something that we're building for the house or something, say, well, let's just nail it a little bit together just to see how it comes together, make sure everything fits, make sure everything works. No, the first time these pieces, these components come together is inside that refinery. So they've got a vessel over there, a vessel over there. They look at a drawing and say, we need this pipe right here. Go find it in that stack of pipe over there that's all laid all over everything. It's not gonna be pipe and a bunch of loose pieces. It's gonna be all welded and painted. They're gonna pick it up, they're gonna bring it up and put it into position, drop some gaskets and bolts in, they're gonna snug it up. So as a pipe drafter, we have to make sure that we gather the exact correct information, especially from the starting point. If we start off wrong, it doesn't matter what all we do working on that pipe. It's wrong if we start off wrong. So when we go back to these pieces of equipment in chapter 8, they talk about how to measure, use our different measuring systems that we use inside the refineries. We don't just show a bunch of dimensions everywhere. That's gonna clutter it up. You're not gonna be able to find the equipment. You're not gonna be able to find the pipe. So what we do, instead of your traditional dimensioning that you've been learning and doing since first semester, we do what is similar to an ordinate dimensioning. Ordinate dimensioning style says we've started a point that we're gonna call 0, 0. So it could be, and those of you that had me for our intermediate CAD, I know we did some drawings like that in there. So this corner right down here is at 0, 0. And so if we've got a circle right there, instead of showing a dimension to that circle like we've been doing, and then having another circle up here showing another dimension, and then another dimension, before long, we've run out of paper just because of the dimensioning. So with ordinate dimensioning, it says, hey, everything on this page dimensions from that point. So I'm not gonna clutter this drawing up and show all of these extra dimensions. I'm just gonna give you some measurements to that point. 3 inches, 6 inches, 9 inches, 1 foot, 0 inches, my plate width. So I'm always giving them that overall. So that's kind of what we're doing in chapter 8. And this may help you. So when you look at chapter 8 and you see all of these different coordinates, they're giving us locations in a real world coordinate system. It is not a real world coordinate system as in, if you take that information that's on that drawing inside of ExxonMobil right over here across the highway, you're not gonna be able to go to the globe or go to latitude and longitude based on that information. Because once you get inside that refinery, they have what's called a benchmark, which is a concrete, usually, concrete column, a concrete pier. It usually has some pipe bollards around it, kind of like what you see when you go to the grocery store. When you pull up at a convenience store to keep people from driving through the building, they're gonna have it well protected. They're gonna call that point 0, 0. And they're gonna give that a rough elevation of 100.0 feet. It's not a true elevation above sea level. Trust me, around here, you're not gonna see 100-foot elevation in southeast Texas, not till you head up north of probably close to Jasper.
Yep.
Or at least above Silsbee.
Uh-huh.
So that is just a rough number that we use, but what it does, it allows us to go out there and dig up to 100 feet. If we drive some piers, some columns down in there to support all these big vessels, which 100 feet is not a lot when you're talking about supporting that much weight and that much height, some of these towers that you see in these refineries, you would not believe what goes on underground right there. So, once we get out there, that 100-foot, just a called elevation guarantees that we're probably not gonna get into negative numbers. When I go out there and I tell them to drive that pier down, and they're bidding that project, and they say, well, how deep does it need to go? It needs to go to elevation 50-foot zero. They know it's not an elevation above sea level, it's worked off that little thing out there, that little monument, that benchmark. And then a little plaque on top that says, this point right here, if you put your finger right here, you're putting your finger on 00 for this facility. You're putting your finger on 100-foot zero for this facility. So we go out there and tell them that we need a pier that's down to 80 feet. We're not giving them negative numbers. We're not asking someone that's out there in the sweat and the heat and the mosquitoes and the mud possibly and all this to start doing math out there before they start doing something as critical as driving that pier down. So having that 100-foot zero pretty much guarantees that we're not gonna get into any negative numbers. We're not gonna be requiring anybody in those conditions to go out there and do math on the fly to make sure something works. So this point will also, like I said, be considered 0, 0. So when I look at this vessel and it says the center of this vessel is at north coordinate 25-foot 0, east coordinate 15-foot 0, that vessel's name is V1. I can work off of that as a pipe drafter. But if it makes you feel better, just say, okay, there's some point out there that has this little concrete pier or something, Mr. P said, that has a coordinate of 0, 0. So if I were standing at that coordinate and I went to the east, so I walked from here east 15 foot, and then I walked north 25 feet, I'm gonna be at the center of that vessel. That allows me to tell someone where to go to an exact location inside that facility. 2 decimals of a foot is what we can go to. And they can have some kind of an instrument that will reflect, that will reflect back to that monument and say, you are this far, just like we do with our phones, just like we do with our GPSs that are based on global satellites. This is based on that little dude somewhere inside that refinery. So if it helps you to work on these, to get out a piece of graph paper and make you a dot somewhere and say, okay, that's 0, 0. This coordinate means instead of saying this dimension, which is gonna start cluttering that drawing up if we start showing all of these dimensions, instead of that, we're just giving you information from a point called 0, on how to get there. North, south, east, or west. It simply says walk north or south this far, walk east or west this far. You will find that piece that you're looking for. And we're not talking about 30s and 40 foot. We're talking about inside a refinery. We're talking about 2,000 feet north, 1,753 foot 2 7/16 to the east. And they're gonna be able to find that correct, whatever it is they're looking for. Maybe it's something big like a vessel. They see it way before they get there. Maybe it's something small like a valve. A hand washing station went out. We can tell them using these coordinates exactly how to get there. We're not gonna say go 3 roads down through this facility, this rack right here, take a right on that road. No, because someone may get off in a unit that they're not supposed to be in. When I was at Unica, I walked in construction. Me and the guys walking to the dining hall over there inside the refinery. We're like, and that rotten egg smell can't be good. And I don't remember what chemical it was, but we were shortcutting to the dining hall. We walked right through a very harmful area as far as, you're supposed to have breathing apparatus when you walk through the word. It can't be good. It smells like rotten egg. That's one of those bad smells you ain't supposed to smell. So then we took a big deep breath and walked on through. So, but we don't want people doing that. We don't want them to accidentally do that. We don't want them turning a truck into a road that they think is a road because we said go down 3 roads. Well, this was just a turn in. they thought it was a road, so they throw this boom around the corner. By the time they can see around the corner, they've already done some damage to something. So this gives us a tracking point to be able to locate items out in there. And like I said, maybe envisioning a point called 0, 0 will help you. But what questions we might have is, what's the north-south distance between V1 and V3? Well, we look over at V1, we find our north-south coordinate there. We look over at V3, we find our north-south coordinate there. What I always recommend is write them down. Write one of them down, then look at your second one, say, is it bigger or smaller? If it's smaller, write it below it. That way, in case you have to subtract, you've already got them in the right position. That's just a habit that I picked up, something that I learned to make it easier on me, to always have that larger number on top. So I'll get a blank piece of paper with lines on it. I'll write one coordinate down once I find it, instead of trying to find both of them and hold my fingers on it. You're gonna see on page 214, it isn't that easy. You can't just look right there, there's one of them, look right there, there's the other. No, you're gonna be flipping through chapters. So you write both of them down. Our rule is, if the coordinates are the same, if they have like coordinates, north and north, the rule is subtract to find that measurement between. So going back to our 0, 0, if this one up here is just like having a measurement that says 25 foot 0, that's what that north 25 foot 0 is telling me. It says from this point called 0, 0, go to the north 25 foot. This one over here has a coordinate of north 15 foot 0. That means from that point called 0, 0, walk to the north 15 foot 0 to find that point. Well, if this is 25 and this is 15, I can visually see that, okay, yes, I did the math right. That number should be smaller, I should be subtracting. So it may be the visual of having that 0, 0 and showing this 25 foot 0 is what that means. That means go to the north from this point, 25 feet. Go to the east from this point, 15 feet. If it helps having that graph paper with that 0, 0 on there, feel free to do it, because there's a lot of room for error on this assignment. So maybe I have the question of, what's the measurement between V1 and V3? The east-west coordinate. So I look at V1, I pull an east coordinate of 15 foot 0. I look over here at V3, I pull a west coordinate, it's larger, 20 foot 0, so I write it on top. Unlike coordinates, we add 20 plus 15, 35 feet between them. That would be the answer to that. Once again, this vessel says from this point, go to the east, 15 foot 0 to get to the center. This vessel says from that same point, 0, 0, go to the west 20 feet. So this measurement is 20 feet over, this one is 15 feet over. The overall measurement, visibly, I can see that I should add those. Like I said, a lot of room for error. Here's another place where people make mistakes. So if you look at this little, remember, all this is gonna be a plan view. Anytime we're looking at these coordinates, unless we're told otherwise, we're understood to have north vertically up. So on this vessel right here, if I were to ask you, what is the north-south measurement between nozzle C at V2, what is the north-south distance between nozzle C on vessel V2 and V1, the center of V1? So you look over there at V1, you say, okay, here's my coordinate here, north, 25 foot 0. You say, okay, nozzle C on vessel 2. Here's vessel 2, here's nozzle C, coming right here in the middle of it. So I've got some coordinates running through it, but this north coordinate does not go through the center of my vessel, or the center of my nozzle. That north coordinate, let me write this up here to look a little bit better for you. There isn't a north coordinate on nozzle C. So some people say, well, I got a north coordinate on this end, there's one right there by it, north 10'0". Light coordinates, I'm gonna subtract 15'0" and move on. That did not get the information you needed. You need a coordinate on this end and a coordinate on this end. You don't have a coordinate on this end. You've got a coordinate near there. So in the condition like this, what I would have to do is something we learned about in chapter 6, the vendor data drawings. I would have to go over to the vendor data drawing for this vessel, which I did a little sketch of over here. And I said, okay, this vessel, here's my side view of my vessel. Here's some concrete supports underneath it. Here's my walking surface out in that facility. We've got an elevation down there. We've got an elevation at the center of the vessel. We look over here, there's our nozzle C. There is a measurement from that support underneath that vessel, that concrete support, just like we have in this glass box over here, just like they have in your chapter 6. That concrete support, those legs underneath that vessel. We have a coordinate right through the center. Now we have a measurement from there to our nozzle. Mr. P, why did they put that coordinate there? Why didn't they just put it in our nozzle? Because our nozzle isn't as important as that support under there. That support under there has to do with the civil department. They've got to build the concrete for it. The vessel people need to know where that support is and how to get to all the nozzles on it. The only person that needs to know just how to get to nozzle C is the pipe drafter. They're not going to go out of the way for each individual pipe drafter. That vessel, I showed one nozzle on it. What if that vessel was a typical vessel that might have had 30 or 40 nozzles on it? So now they gotta show a coordinate for all of them. So one pipe drafter doesn't say, well, they didn't show my information. When you get into this, and something you'll find out a lot next semester, and a little bit in this chapter 9 exercises, is that these drawings that we're working off of are not geared for the pipe drafter. They're not geared for the pipe drafter just to look over there and say, all right, first semester AutoCAD, there's my measurement, there's my numbers I need right there, click, 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 type, type, type. It's not like that. The pipe drafter may spend as much time gathering information as they do drawing that piece of pipe. Because the pipe drafter has to say, well, that's great they gave us that information. That's not what I need. But I can look over at this vendor data drawing and say, okay, from that support, it's a measurement of 2 foot to the center of my nozzle. From that support, which is what gets me, the vessel department, the civil department, gives us the info we need. From there to nozzle C is 2'0". So if this is north 4'0", this is north 10'0", I'm going another 2 foot. That's gonna be north 12'0", so I had my 25 from up there. Now I've got a coordinate here. I had to look up some information, do a little bit of math, but now I've got a coordinate there. Now I can do the math, find the distance in between. So when you get to the second exercise at the end of chapter 9, the one that's on page 214, it's not gonna be like the first page. The first page you're gonna look at and say, oh, this assignment isn't that bad. Why did he go over all that instruction? Look, it's all right here. It's just a matter of math. I can see it. It's easy. Not everybody's gonna be able to see it on that first page. Not everybody's gonna click on that first page. That's why I did all of this. And then you turn to the second page and say, well, uh-oh, this just got real. Well, on the second page is where you're gonna have stuff like this. It's gonna ask you for a measurement or a dimension to one of these nozzles. You're gonna have to go find that vessel. You're gonna have to go to that vendor data drawing. You're gonna have to look up some information about that nozzle to be able to go back and do your math for the answer you're looking for. So here's something to make note of. When you're doing that second page, you've got 4 facilities, four little units. Unit 01, 02, 03, and 04. So if you want to look at that second page, page 214, you can see that some of those pieces of equipment start with 01. You'll see one of those little rectangular areas, all of those pieces of equipment, the vessels, the pumps, the structurals, everything starts with 01 dash something. And then you'll see another little square a rectangle next to it. all of those pieces of equipment start with 02 dash. And then another one, everything starts with 03 dash, and then your other one that starts with 04 dash. There are 4 little mini units made up on that page, 214. Here's what you need to know about that. That is the page that you're gonna have to go to some of those vendor data drawings and look up some of those vessels, some of those pumps possibly. So if your equipment starts with 01, that means you are in unit 1, you will find those pieces of equipment in chapter 10. So any equipment that starts with 01, when you're looking up data, when you're looking for that vendor data drawing that shows you this chart and everything, gives you information about that piece of equipment, if it starts with 01, it will be in chapter 10. If it starts with either 02, 3, or 4, you will look up those pieces of equipment in chapter 15.
You said 02, 03? 02 and 03?
What?
2, 3, and 4?
2, 3, and 4 is gonna be in chapter 15, yes. Remember, that's just whenever you come to a scenario like what I had here. I needed a coordinate at the center of that nozzle so that I could go through and finish this exercise, finish that measurement. I had one coordinate on one end, but not on the other end. I had a coordinate near it. I had to go find a dimension from what I knew, which was a coordinate at the bottom of that support that worked for the civil department, the structural department, the electrical, the vessel people. I have to take that information and find out how to get from my known information, which is a coordinate at the center of the vessel, to what I'm looking for, which is a coordinate at the center of my nozzle. Alright. The third page of your assignment, which is page 215. 215 is what's called an elevation view. All of the rest of these and the majority of what you're working off of is gonna be plan views. Plan views, remember, will always have a north arrow, normally pointed straight up. Plan views are always looking down on it. It's what we used to call a top view. It's a grown-up top view. It's got a north arrow now. It's got a real placement in the world. So once we go and look at the outside of that, it is not called a front view, right side view. It is called an elevation. The elevation is based on which side you're standing on. So if I were to come up to your house and I'm standing on the north side of your house looking at it, that would be called a north elevation. It's not the direction you're facing, it's the side you're standing on that you label those views with. So that third page is an elevation view. You're walking up to that refinery, up to that facility. You're seeing all the vessels sticking up like this instead of flying over in a plane, like a plan view. On that view, what you're looking at and you're working with there is what's called elevations. Elevations are just heights. It's the same thing as this over here. If I had a vertical vessel, and I had all these nozzles coming off of this vessel up here, instead of me showing a measurement like this and another measurement here, steadily getting more expansive, now I gotta switch to this side because I've got nozzles on that side. Before long, we're starting to lose our drawing because of all the dimensions we've got coming off of it. But we have to show that information. So instead of showing all those dimensions, we said, look, let's just leave all this stuff off. And what we'll do is we'll go down here and give this a number. 207'0", elevation 207'0". Did we just randomly give that? No. It was all based on something to do with that point somewhere in that facility. That means that wherever that little dude is right there, we're 107 foot vertically higher than that. We're not straight above it, That's based on your north-south coordinates, how far away from that point you are. We're talking about a height when we're talking about elevation. So instead of going through and showing all those dimensions that really clutter up the drawing, I can just come out here and say elevation 215.0, elevation 220.0, elevation 225.0. Lot neater, still gives the same information, gives correct, exact information without cluttering up the drawing. So once you get out into the petrochem world, we rarely show any true dimensions, like what y'all been learning to do. Mr. P, why did we spend so much time? Well, if you took me for your CAD classes, you didn't spend a lot of time on dimensioning. Because once you get your dimensions set up, if you can draw it right, you can dimension it. And then once you get out in the petrochem or out in the real world industry, you find out that you don't show hardly any dimensions at all. Architecturally, yeah, we dimensioned everything because someone's gonna be out there with a tape measure, measuring that stuff. Most of your other industries, no, we dimension in other ways such as this. So when you're working on that third page, you're gonna see stuff like this. You're gonna have a vessel that you got a side view of. You've got the concrete below it. You've got your support sticking up. You've got your vessel with your nozzles coming off of it. You're normally given an elevation at the center of that vessel. So if I were to go through and say, what is this measurement right here? Once again, just like the other way, you're gonna gather information. You're gonna say, well, what do I know? Well, I know that this is an elevation of 100.0 right through the center. This is elevation 100.0. So if they showed those measurements that Mr. P said that they don't like to show because it clutters up the drawing, I know that that measurement would be shown something like this. This elevation is 100. This is 108. That means it is 8 feet above, 8 feet tall off that concrete right there. So we were able to give that measurement, but not clutter up the drawing by showing it. Does everybody understand how that works with your elevations like that? Might be something different than the whole XY00 thing. So once again, it's just a different way of showing that measurement. So what we have to do on this vessel is we say, okay, that measurement is 8.0. If I only knew this measurement, I could add them together and there's my answer. That information comes from what's called a nozzle schedule. So in chapter 6, where they showed you and talked to you about the different types of vessels we encounter, each one of those vessels had what's called a nozzle schedule. Same thing with the pumps. Each one of your pumps had that nozzle schedule up there in the corner. It's a little chart, but it gives us some information. It gives us the names of the different nozzles. Sometimes it's A, B, C, D. Sometimes it's numeric names. Sometimes it's both, N1, N2. It tells us what's the purpose of that nozzle. It's liquid in, that's commodity coming in. How many of them are there? There's just one. What's the size? 8-inch nominal pipe size. Our pound rating for our flanges and valves, 150 pound. What type of face do we have? Raised face. And then the big one on the end down there, projection. We found out, or we learned in chapter 6, that projection, when it comes to our equipment, is defined as a distance from the center of that piece of equipment to the face of their flange. So that means that that distance from the center of this vessel to the face of their flange, according to that projection right there, is 2.0. That means that the answer to that one right there would be 10.0. Does everybody get that? Here's the kicker. As a pipe drafter, that is where our work starts. More specifically though, it starts on the other side of that gasket that will be between that flange and our pipe. That 1/8 of an inch gasket that we learned about in the flange chapter 5, I believe. We talked about anytime you have two flange faces, whether it's two flanges, two of these dudes sandwiched up to each other. Maybe it's one of those and a valve, a flanged valve. Anytime we have two of these metal surfaces being bolted together like that, we can't have that commodity getting out. What if that flange got dropped while they were on the way over there to fit it up to make that pipe system? What if when it was being shipped, it got a ding, another flange got dropped on it when they were stacking them up? They're carrying a pallet of flanges over on a forklift, maybe they tumble over. A lot of things can happen to that metal face of that flange that says that, hey, that thing's not gonna seal on. We gotta have something squishable, something pliable in between those two metal surfaces that we can squish in there and fill all those imperfections. That's the gasket, that's the purpose of the gasket, making a leak-proof connection. So as a pipe drafter, we say, okay, I can calculate my way up. This is an 8-foot measurement, that's a 2-foot measurement. That means the face of their flange is at elevation 100 foot 0 inches. Me as a pipe drafter has to say, and then we've got a gasket right there of 1/8 of an inch. So my pipe, when I'm starting to calculate mine, my actual elevation that I'm gonna use for that end, 0 and 1/8, because that's where my pipe starts at. And I'm gonna say throw a gasket in there. We're gonna have a gasket in there for that, but that's not gonna be part of my drawing. My drawing will physically start at the face of my flange. So next semester, when you're starting to draw and you're calculating this stuff, remember, we've gotta say, all right, here's what they give us: 8 foot to the center of the vessel, 2 foot to the face of their flange, 1/8 of an inch for the gasket, boom, that's where my drawing starts at as a pipe drafter. That 1/8 of an inch, depending on the number of double flanges or flanges and valves that you have, if you forget to account for that 1/8 of an inch, just like some of you saw on the fitting makeup I gave back a while ago, if you forget to account for that 1/8 of an inch gasket in there, over the course of that spool piece, if it says, all right, it starts at a flange and we've got a valve, another valve, that's 1, 2, 3, 4, 5, and then another gasket on the end, 6 gaskets just in that straight run right there, 6/8 of an inch, 3/4 of an inch, that ain't gonna work. They're not gonna be able to get that pipe in there. That's not gonna happen too many times with the same company. Oops, I forgot the gasket, boss. Look, we had to shut the job down. What do you mean, sorry? You're bad. No, your box, your desk, put it in there and head out. That's what it's gonna be. After a while, it's not gonna be your first mistake, but it will happen if you allow that to happen. If you're okay with just forgetting an 1/8 of an inch, boss, that 1/8 of an inch, that pipe's not just going from here to here, that 1/8 of an inch is gonna come into play. It's gonna add up and it's gonna make something wrong. So any questions on the chapter 9 exercises? Like I said, each one of them's got 10 question and answers, their measurements, elevations that you gotta look up. 10 fill in the blanks. Put them on a document, just in Word like that, type them up like that. I don't need the handout, I don't need to see your math, but if you have it, that'll help. This is one of the tests that we usually do during the semester. I've got 2 or 3 that I flip-flop around with, that this is one that we usually do, because this is one that's gonna be very critical next semester. When you come in here and I'm trying to teach you how to draw and find and calculate lengths of pipe. That doesn't sound familiar, Mr. P. Yeah, you'll remember these exercises, you'll remember the test, and you'll cuss them, and that's okay. But you'll learn it, because it is something that pipers do day in and day out. That's how we get our information. It's not first semester, second semester, here, honey, draw this. It's, hey, here's your stuff. You're doing these pipes. Come see me if you need something, but I really don't expect to see you, and I sure hope I don't, because it's all in there. All you gotta do is look for it and find it. That's what it's gonna be with these pipe projects. All right, so any questions on what you're working on? Flange exercise for sure before you leave. Your fitting makeups, if you need some more of these blanks, they're up here on the desk. Take them with you if you want to go home and work on and modify or submit your answers. Remember, those did not get recorded. So if you want any of those grades, or you want all of those grades, if you're good with it, make sure and put them or turn them back in. Otherwise, that grade is not going to get recorded. I did not keep those grades. Some of you'll probably be thankful for that. All right, that's it. Y'all have a good evening. Make sure you have your flange exercise in before you leave. I'm gonna try not to cough anymore because my throat's killing me.